Hi, welcome to AVSET Math. In this video, we'll look at another common integer equation type, the linear two-variable equation. Now, I put an asterisk here to indicate that for the AMC, we'll focus on a slightly simplified version of this equation type, and I'll say more about that later. So let's look at our example problem. We want to find the number of ordered pairs of positive integers x, y that satisfy the equation 3x plus 5y is equal to 501. Now, the simplification in this equation comes from the fact that the constant term 501 is evenly divisible by one of the coefficients, in this case the coefficient 3. And our solution method will look for the coefficient that divides evenly into the constant term and divide both sides of the equation by that coefficient. So in this case, we'll divide both sides of the equation by 3. And that leaves us with x plus 5/3 y is equal to 167. And at this point, we can notice something very useful in that the first term is an integer, the constant term is still an integer, and the only way this equation can be satisfied is if this middle term here is also an integer. And we see the only way that that can happen is if y is a multiple of 3. So we can write y as 3 times some other integer, n. And we can take this y equal 3n, substitute it back into this equation, and we find that x plus 5/3 of 3n is equal to 167. 3's cancel. Bring the 5n to the other side, and we find that x is equal to 167 minus 5n. And at this point, we have to find out what values of n will satisfy the requirement that both x and y are positive integers. So for the case of y, we find that n of 1 or 2 or 3 will satisfy that requirement. So essentially, we want n greater than or equal to 1. And for the second equation, we see that n equal 1 works, n equal 2 works, but at some value of n, x will become negative. So we want to find out the threshold value of n that will cause x to become negative. And probably the simplest way to do that is to find what value of n will make x equal 0. So we can basically set x equal to 0 over to the side here, and we find that 5n is 167, and then n is equal to 33 and some change. So for n equal to 33, x is still positive, and when n equals 34, it crosses the threshold of x equals 0, and then x becomes negative. So essentially for n less than or equal to 33, x will be positive. Now, combining these two requirements, that n has to be greater than 1, but it also has to be less than or equal to 33, we find then that there are 33 values of n that will lead to positive integer solutions in x and y. So we basically find then that there are 33 solutions in total. And that's the answer to the original question. Now, I should say that any modern question of this type will be disguised in a word problem, and you'll see that in the problem set for this video. Also, what if neither coefficient divides evenly into the constant term? So for example, what if we had 3x plus 5y is equal to 41, for example? Well, that's a bit more complicated, but fortunately it's also quite rare for the AMC, so we'll ignore that case for the time being. So with that, go ahead and look at the problem set in the description section along with the video examples, and we'll see you at the next video. Take care. Bye-bye.